If the past still exists, etched permanently into the fabric of space-time, what about the future? Has it already happened? Are we just passengers on a track laid out long before we were born? Or do our choices actually matter? Is free will real, or just a comforting illusion? In our last exploration, we discovered the astonishing idea of the block universe, a model from Einstein's theory of relativity suggesting that time is not a flowing river, but a four-dimensional structure. In this model, the past, present, and future all exist at once, like different rooms in a vast mansion. We only perceive a single room, our now, but that doesn't mean the others have vanished or aren't real. So if the past still exists, the natural follow-up is, what about the future? Is it already there, waiting for us to arrive? Or do we somehow forge it as we move forward? This question takes us straight into one of the most enduring philosophical and scientific debates in history, the conflict between determinism and free will. In a deterministic universe, everything unfolds like a perfect machine. If you knew the exact position and momentum of every particle at one moment in time, you could, in theory, calculate the entire future of the universe. This is what classical physics once promised, a clean, orderly cosmos where nothing is left to chance. No surprises, no real choices, just causes leading to effects, playing out like a meticulously arranged domino chain. From that perspective, your entire life, your triumphs, heartbreaks, even the moment you're watching this video, was already written into the universe at the instant of the Big Bang. It's like your life is a script, printed from beginning to end, and you are merely turning the pages. You feel like you're choosing, but really, you're discovering what was always going to happen. And let's be honest, this is a deeply unsettling idea. It contradicts our sense of agency. We're not just passive observers of our lives. We feel like active participants. We reflect, decide, regret, and aspire. We hope our choices matter. So how do we reconcile that with the idea that the future might already exist? It's important to recognize that this deterministic view doesn't come from speculation. It arises directly from the mathematics of classical physics. Newton's laws, for example, are time-symmetric. They don't care which direction time flows, and they don't include any mechanism for spontaneity. If you could input the present with infinite precision, you could, at least in theory, predict the future with perfect accuracy. But there's a big catch. The real universe is more complicated than Newton's equations. In the early 20th century, a scientific revolution began to reshape our understanding of reality. That revolution was called quantum mechanics, and it would challenge everything we thought we knew about determinism. But before we go there, let's sit with this thought. If the future exists, frozen in space-time like the past, then what does that mean for you right now? It might mean that your actions are embedded in the structure of the universe, that they were always going to happen. But it also might mean that what you're doing now, choosing to learn, to question, to understand, was always part of the story too. Maybe it's not about whether the script is written. Maybe it's about the way we read it. We don't experience time all at once. We move through it, page by page, moment by moment, and in each moment, we feel the weight and wonder of choice. Whether that's an illusion or a deeper kind of truth is something we'll explore next. If classical physics paints a picture of a perfectly predictable universe, where the future is just as fixed as the past, then quantum mechanics steps onto the stage like a disruptive artist and starts tearing that canvas apart. Quantum mechanics is one of the most successful and precise scientific theories ever developed. It governs the behavior of the tiniest things in the universe, electrons, photons, atoms, and it works with astonishing accuracy. But it also introduces something classical physics could never account for: inherent uncertainty. At the heart of quantum mechanics is a principle known as superposition. Instead of saying a particle is here or there, quantum mechanics says it can exist in a combination of both states until you measure it. When you do, the particle seems to choose a position or state. Until that moment, it's described only by a wave function, a mathematical object that encodes all possible outcomes but doesn't tell you which one will happen. This is not just a limitation in our knowledge. This is how reality behaves at the quantum level. You can't predict the exact outcome of a measurement. You can only calculate the probability of each result. So, what does this mean for the future? If events unfold based on probabilities, not certainties, then the future can't be fully determined in advance. Right? Well, yes and no. It's true that quantum mechanics doesn't allow us to predict the future with perfect certainty, but it doesn't throw us into pure randomness either. The probabilities follow strict mathematical rules. The outcomes we see in the lab, no matter how strange, occur within well-defined patterns. The universe isn't chaotic, it's probabilistic. And there's another layer to consider: interpretations of quantum mechanics. Some scientists interpret the randomness as truly fundamental. This is the Copenhagen interpretation, which says the universe behaves probabilistically until an observation collapses the wave function and picks a single outcome. But other interpretations push back on that idea. Take the many worlds interpretation, for example. It proposes that every possible outcome of a quantum event actually occurs, but in a different branch of the universe. When you measure a particle and get one result, there's another version of you in another universe who got the other result. In this view, the universe doesn't randomly choose one outcome. It splits, and all outcomes are realized. This solves the randomness problem, but it leads us right back to something equally unnerving. Every possible future already exists, just in different versions of reality. Your choices don't eliminate possibilities. They simply determine which version of you experiences which outcome. Even interpretations like pilot wave theory try to bring determinism back in by adding hidden variables that steer outcomes in a predictable way. But these interpretations are not universally accepted, and they come with their own strange baggage. In all cases, we run into a similar conclusion. The future may not be fixed in a classical sense, but it might still be fully structured, whether through branching timelines, probabilistic rules, or hidden variables. But here's the twist. Even if the universe contains randomness, randomness is not the same as free will. A random coin flip doesn't mean you made a choice. If your brain decided something based on a quantum event, that doesn't mean you willed it to happen. It just means you're part of a system that reacts in unpredictable ways. So, where does that leave free will? It's complicated. Quantum mechanics may have shattered the idea of a perfectly predictable universe, but it hasn't handed us freedom on a silver platter. Instead, it has revealed a deeper mystery. The universe is neither entirely determined nor entirely chaotic. It follows laws, but leaves room for uncertainty. That uncertainty might just be a crack in the door, a space where something like free will could exist. Or it might be nothing more than the appearance of choice in a system we still don't fully understand. The future, then, is not just one thread. It may be a tangle of threads, twisting through the quantum fabric of the cosmos. If the universe is a block, its past, present, and future already embedded in a four-dimensional fabric, and if quantum mechanics only adds layers of probability or branching realities, then a troubling question remains. What does that mean for us? Are our choices real, or just illusions we tell ourselves to feel in control? Let's go back to that idea of reading a book. In the block universe model, your life might already be written, page after page, chapter after chapter, but you're not flipping through it all at once. You're reading it line by line, moment by moment. You don't know what's coming next, even if the ending is already printed. From your perspective inside the story, every choice feels real. You hesitate, you reflect, you act. You could have done something else. At least that's how it feels. So even if all your decisions are already part of the cosmic script, you still experience each one as new and uncertain. This is where some philosophers argue that free will and determinism aren't necessarily in conflict. They propose a view called compatibilism, the idea that we can be free, even in a determined world. How? Because freedom doesn't require that we act outside the laws of physics. It just means that our actions come from us, from who we are. Our brains, our memories, our values, and our goals. All of these shape our decisions. Even if the outcome is technically predictable by some cosmic supercomputer, the process of choosing still matters. Think about it this way. When a river flows, its path is shaped by the terrain. The water doesn't pick a direction randomly. It moves according to gravity, elevation, and the shape of the land. Your mind, in the same way, moves through decision-making not by chance, but by the terrain of your life. You think, feel, analyze, and act. That's not nothing. That's agency. Even in a fully deterministic world, your thoughts and actions are still yours. They reflect who you are, and they make a difference because your actions ripple out, shaping the next page of the story. And if quantum mechanics introduces true randomness, that still doesn't undermine your freedom. Because freedom isn't about rolling a cosmic dice. It's about being the author of your reasons, making decisions with intention, responding to the world in a way that aligns with your sense of purpose. So maybe free will isn't the power to defy physics. It's the ability to live meaningfully within the structure of reality, to be aware of your part in the story, to own it. This brings us to a deeper kind of freedom. Not the freedom to break the rules of the universe, but the freedom to understand them and choose how you respond. Even if your future already exists, you haven't experienced it yet. You're still discovering it. And that experience matters. When you wake up tomorrow and decide to change something, your attitude, your habits, your perspective, that change is still real to you. It may have always been part of the script, but now it's something you're living, not just something that exists in theory. So is free will real? That depends on how you define it. But one thing is certain, your experience of choice, of growth, of meaning, is as real as anything else in the universe. In a cosmos where time doesn't flow, where futures may already exist, and where randomness lurks at the edges of certainty, maybe the greatest mystery isn't whether we're free. Maybe the real mystery is this: how does consciousness make us feel free, even in a universe that might already know what comes next? So if our lives are shaped by consciousness, could that mean consciousness itself lies beyond the boundaries of space-time? Could it be the one force that doesn't obey the rules? Discover the next mystery in our video. Is consciousness outside of time, only here on the vast unknown?